Very well. So what about your denominator? What would be the sample space? Think about it this way. You have 3 people. You have 3 people. And for the first person, what would be the birthday? One of those 365 days. So 365 days. For the second person, guys, I'm calculating the sample space. I'm not calculating the numerator or my event. It's just the sample space. We have to consider all of the options. For the second person, for the third person, it's going to be the same, 365, 365. Remember the fundamental principle of counting? Now you have to multiply all of these. So on the denominator, you get 365 times 365 times 365. Now you have some algebra to do. First of all, simplify this as much as you can. 365, 365, you get 1 minus 364 times 363 divided by 365 times 365. So let's do the calculation. Let's use our calculator to calculate this number for us. 1 minus 364 times 364 divided by 365 times 365 is equal to 0.0082. So what is this percent? Take a look at this. Here you have 0.0084. In the best case scenario, we can say that it might be close to 1%, but it's actually less than 1%. Less than 1%. What's the meaning of that? It means that the probability is very small. It is a very small probability. Well, let us move on to page 2. Another example for you. So in this example, this is an example of lottery. So in this example, what do we have? We have the following situation. A gambler selects 6 numbers. 6 numbers between, what are the numbers? Between 1 to 44. If all of those 6 numbers match the number, then that person wins the first prize. So if all of these numbers match the 6 meaning numbers, then the gambler wins the first prize. Okay, what's that probability? What is the probability that that person, he or she, actually wins the first prize? Wins the first prize. We have a probability and we have to do a little bit of algebra. Wins the first prize. This is your event. What do you think? Should we use E, or is it better to use the complement of E? Think about it. E is the event wins the first prize. How that person wins the first prize? If all of these numbers match the 6 winning numbers. So that's the interpretation. So you can say that, hey, E is equivalent to saying that all 6 numbers match the winning numbers. All of them. So what would be the complement of this sentence? What would be the complement of this event? All of them are matching. What would be the complement? So I'm going to argue that let us use the event itself. Why is that? Because it's easy. You only have one choice, one option, and that choice would be winning numbers. So there's no point using the complement of this event. In previous example, it was easier to use the complement of this event, but this event is actually has cardinality equals to 1. The cardinality of this event is nothing but 1. What's the cardinality? Is just selecting the right numbers. That's it. So on your numerator, the cardinality of all 6 numbers match the winning numbers is equal to n of that event 1. How many options do you have for the first number? 1 option. It must be the correct value. It must be the correct number. The second one, 1. It must be the correct value, and so on. What about the denominator? What would be the sample space? So the sample space is actually selecting 6 digits, 6 numbers out of 1 through 44 numbers. So selecting 6 numbers out of 44. Is this a permutation? Is ordering important for you, or is just a selection, or you just randomly select? It is actually combination. So the combination of 6 numbers out of 40. So let us calculate them. The combination of 6 objects out of 44 is 44 factorial divided by 44 minus 6 factorial, 38 factorial times 6 factorial. So this is equal to 44 times 43 times 42 times 41 times 40 times 39 divided by, I have 38 factorial, I'm canceling out 38 factorial and 38 factorial. What goes on the denominator? My denominator is 6 factorial, which is 6 times 5 times 4 times 3 times 2 times 1. Okay, here I have 2, 4, and 5. I can cancel out 40. What else I have here? I have 6 and 7. I get 7 here. So if I do the calculation, the probability is equal to 1 divided by, let me see, here I can cancel out 3, and here I have 13. So I get 44 times 43 times 7 times, I have 13. I have 41 and 13. So let's do the calculation here. Use our calculator. 1 on the numerator. Okay, I don't need that. Let me just calculate my denominator. 7,059,1 over 7,059 and 15. Okay, as you can see, the denominator is very huge. It's very big. What's the meaning of this for the fraction? It means means that you get a very small fraction. You get a very small number. So since our denominator is a big number, it makes the fraction to be very small. What's the meaning of that? It means that this probability is very small. How about what's the probability of someone being hit by lightning? Think about it. You might not think about it that way and say, hey, the probability, the chance is very small. The same for the lottery. Let's take a look at our page 3. Suppose you're playing roulette, concentrating on the $1 single number bet. At one point, you were $10 ahead, but now you are $14 behind. So $10 ahead and $14 behind. How much should you expect? What would be your expectation to win or lose on the average if you place the bet many times? So this is actually a question, and the answer is related to expected value. Let us take a look at the analysis and argument here. The probability of winning a single number bet is 1/38 because there are 38 numbers on the roulette wheel and only one of them is the subject of the bet. This means that if you place the bet a large number of times, it's most likely that you will win once for every 38 times you place the bet. And of course, and lose the other 37 times. When you win $35 because the house odds are 35-1. When you lose, you actually lose $1. So what would be your average profit? Your average profit is winning $35 plus 37 times you're trying and you're losing $1. So you put a negative sign next to your $1, you get 35. You have positive, negative, you get negative number, 35 minus 37, which is -2, divided by 38. How many times? 38. Well, it is approximately a negative number. In this case, it means that you are losing money. This is called the expected value of a $1 single number bet, because you should expect to lose about a nickel for every dollar you bet if you play the game a long time. If you play a few times, anything could happen. You could win every single bet, though it's not likely. The house makes the bet so many times that it can be certain that its profit will be $0.053 per dollar bet. Well, the standard way to find the expected value of an experiment is to multiply the value of each outcome of the experiment by the probability. So you need the probability of that outcome and add the results. Here the experiment is placing a $1 single number bet in roulette. The outcomes are winning the bet and losing the bet. Okay, 2 outcomes. The values of the outcomes are, okay, if you win, you earn $35, and -1, it means that you lost $1. The probabilities of outcome are 1 out of 38 times, $35 once. You win once out of 38 times, and 37 divided by 38, you lost the value. So the expected value will be 35 times 1 over 38 plus -1, you lost -1, you lost $1, times 37, so 37 times the rest of the times divided by 38, and it is roughly 0.053. You're losing money. We can use the table, finding the expected value, outcome, winning, losing, value, of course, 35, showing that you earned money, -1, it means that you lost $1, and the probability, 1 out of 38 and 37 out of 38. Very well. This is the table representing the value, the outcome, and the probability. It makes it easier for us to find the expected value. Well, finding an expected value of a bet is very similar to finding your average test score in a class. That's interesting. Suppose that you are a student in a class in which you have taken 4 tests. If your scores were 80%, 76%, 90%, and 90%, your average test score would be, okay, 80% plus 76% plus you have 290%, so you're multiplying 2 by 90, divide everything by 4. If you do the calculation, it is equal to 84, and since it's in percentage, you put percentage sign next to it. Or equivalently, 80. So you earned 80%. You had 4 exams, 4 tests. So 1 at a time, 1 out of 4 times, plus you earned 76 in 1 exam. So 1 out of 4, plus you earned 90% in two different tests. So 90 times 2/4. Very well. So as you can see, the calculations are the same. It is 84%. So the difference between finding the average test score and finding the expected value of a bet, what's the difference? The huge difference, the main difference is that with the average test score, you are summarizing what has happened. So you're not expecting something to gain. You already know the results. Whereas with a bet, you are using probabilities to project what will happen. Let us move on to next page. Let us go over another example. We're going to use our expected value. On page 4, we have the following example. So this is our scenario here. This is page. So the information that are given to you is that by analyzing her sales record, a saleswoman has found that her weekly commissions have the probabilities below. Weekly commissions. So the table is given to us. We have commission and the probability of the commission. Well, the first commission, 0. The probability is 5%. The second commission, $100, okay, $100 with probability 15%, 0.15. The next one is $200, $200 with probability equals to 25%, 0.25. Then you have, let's see, $300, 45%. $300, 0.45, 45%, and the last commission is $400, which is 10%. $400, which is 10%. So 0.1. Okay. Question says, find the saleswoman's expected commission. What is the expected commission? Well, we know that to find the expected value, they have to take each value multiplied by its probability, add it to the multiplication of next value and its probability, add it to the multiplication of that value and its probability, and continue the process. So let us find it. The expected value, the expected commission is equal to 0 times 5%. 0 times 0.05 plus 100 times 15%, 100 times 15% plus 200 times 25%, 200 times 25. We have 300 times 45%, and finally we have 400 times 10%. So 400 times 10%. So let us do the calculation. This is equal to 0, 0 times any number is equal to 0, 0 plus. So here you get 15 plus, here if you multiply these two, you get 50 plus, here if you multiply these two, 135 plus, if you multiply these two, you get, okay, let's add these together, you get 65, here you get 200 and $240. This is the expected value. So, what's the use of expected value here? Let us take a look at the second example, which is actually a question. So, let me write down this here. We have $240. $240. So, question. If this person had been offered a new job that has guaranteed weekly salary, that has a fixed weekly salary of $290. What would be the decision? What would be the decision? So think about it this way. The expected value is 240, but the new job actually offers 290 per week. So should the person accept this new job, or should the person stick to the previous job? What would be the decision here? What's the difference between these two numbers? 290, which is higher than 240. $50 more. So this 290 and the difference shows that it's a good idea to accept the new job.